Yeah. What could I teach you in chemistry in everyday life? Any other chapter after this?
No, no, the rest I have, yeah, covered.
You have covered. Okay, not a problem. Mm, 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 mm.
But 11th we can revise.
No, no, not a problem. Just
Okay.
thinking. Okay. See, I'm gonna provide notes for this. I'm just showing you what is what is present in this chapter, what topic, and this. Basically,
Okay.
this chapter deals with drugs and their classification. Drugs and their classification.
Okay.
Okay,
Yeah.
and the classification has a base like in biomolecules. We had source and then arrangement like that.
Yeah.
Classification of drugs on the basis of pharmacological, on the basis of this is basically a whole theoretical part. Pharmacological, pharmacological effect. So basically, it is based on pharmacological effect. It is useful for doctors, pharma, medicines, right?
Yes, yes, yes.
Some of the drugs are like you can see that is used in our treatment. So on the basis of pharmacological, then comes on the basis of drug action. In lot of the process of biochemical process, basically in biochemical process we use drug. Then on the basis of chemical structure, there are some chemical structure of the drugs that uh, it is also basically all are related to the pharma, that means medicines.
Okay, okay.
And then comes the drug enzymes as a drug target, like catalytic action of do you know what is catalyst?
Yes, yes, yeah. It increases the rate of reaction.
Yeah, it increases the rate of reaction, but in that chapter, what we say, surface chemistry, you have seen that there will be a positive catalyst and there will be a negative catalyst, right? In
Yeah,
positive catalyst, this is a rate increases, and this, according to our
yes,
requirement, it decreases, right?
yeah, yeah.
And you also have seen that there was enzyme part in which lock and key was there. Yes or no? Have you remembered?
Yeah.
Yes or no?
Uh,
No.
locking key.
Okay. Let me just show you.
Yeah.
Let me just draw the diagram. You'll get it. If you have, okay. So this was like you can draw it on or in your own way. This is like this. I'm going to draw, and this is your E, and here it is. So we need to make it like this. Are you getting my point? This will combine with this. So lock and key. This is S,
Okay.
enzyme and substrate. Then what will happen? This substrate, that means reactant. So this enzyme will come and it will divide into two parts, product plus product. Are you getting my point?
Yeah, yeah, yeah.
So
Yes,
this
yes.
is lock and key. If you are going to join them, they will fit with each other. They will fit with each other like this. Let me show you. They will fit with each other. This will go inside and it will be like, are you getting my
Yes.
point?
Yes, yes, yeah, yeah.
They will be fitting with each other. So after this, this will be divided into two products. So this is what I wanted to tell
Okay.
you. Then there is a biological part like receptor as drug test, animal cell, and all. I will provide notes for you. You can just go through it and you will be able to answer it easily.
Okay.
Okay.
Yeah.
So can we do the uh in which chapter you want a revision for class 11th, 12th, which chapter?
Okay, yeah, yeah. For 11th, I want. So, wait, let me just take a list.
Yeah, just take your time. Yes, Davis.
Yeah, yeah. Okay, let's do states of matter. Yeah.
Okay, let's do states of matter. So first of all, for states of matter, I would like to have some gas laws, right?
Ah, yes, yeah. Yeah.
And gas laws, let's just start with the Boyle's, and you are gonna tell me what is Boyle's law. So pressure inversely proportional to volume at constant. Whatever I'm going to write in bracket
Yeah.
or parenthesis, that will be constant, right? Okay.
Okay.
Okay. So what I want to tell you, at number constant number of moles and temperature. So here you can see P will be equal to K upon V. K is constant. Okay.
Yeah.
So it is understood that if you are going to increase pressure, volume will decrease. Is that clear?
Okay.
Now, if I'm going to give you graph is very important in this chapter. If I'm going to give you this graph, so what will be the graph for this? It will be like this, parabola, hyperbola. This will
Yes.
be like this,
Yeah.
hyperbola. So what
Yeah.
if I'm going to give you to plot a graph between pressure and 1 by V?
Yeah, it'll be straight line
It
upwards.
will be a straight line. It will be a
Yeah.
straight line, right? What if I'm going to give you PV versus P?
Uh,
Yeah, it is easy. Just get the equation. This is your equation.
yeah.
And you can see PV is equal to K. That means constant.
Yes.
Whatever present here and here, you can see PV is constant, so the graph will be
Oh,
constant.
okay. Yes, yes. Okay. Yeah.
If it will be like PV versus B, same graph.
Yes.
If it will be like PV here and P here, graph PV is constant. That's all we
Yes.
know.
Yes.
Okay.
Yeah, yeah, got it.
What if I'm going to ask you log P log B?
Wait. Mm,
To plot a graph, you need an equation. So
yeah, yeah.
If you're unable to do it, just let me know.
Uh, yeah, it'll be directly proportional, right? Straight line.
Straight
With
line.
yeah, I think it'll have intercept like log k.
Okay, what I want to ask you
Okay.
is that a straight line is this, a straight line is this, a straight line is this, and a straight line is also this. So this is your A, B, C, D. Which one is the straight line that you are talking about?
Oh, okay, okay, wait. Yeah, it's B, B.
B, that is going upward.
Yeah, yeah, yeah,
Okay. Okay. Let me just check.
yeah.
We have this PV is equal to K, right?
Yes.
So if PV is equal to K, we need log PV we can write is equal to K. Then we can write log P plus log V. That will be equal to log K, right?
Yeah, yes.
Now we have log V, log P, but this is on x-axis, so I'm going to move it to this part. So log
Yeah,
P will be equal to log K minus log V, right?
yeah. Oh,
Now,
minus
as
log,
you
yes.
can see, yeah, now you can see y is directly proportional to minus x. That means basically it will be downward.
Okay.
Yes or no?
Yeah,
Okay. What if I'm going to give you to plot a graph between log p versus log 1 by v? This one graph from the Boyle's law will be very helpful for other laws as well, because you know the
okay.
relation between what is Charles' law, what is Galois X law. You know the
Yes.
relation. Now you will find the how to calculate the how to draw the graph with this, and you can apply in all of them.
Okay.
Yeah.
Yeah, yeah. This time it is like positive, like upward, but yeah, intercept is also log k. Yeah.
Okay. That means like this. Are you
Wait, wait,
talking about this?
wait, 1 minute. No, no, it will be like D, like the D one.
Okay. That means your intercept is negative. You are
Uh,
saying this, right?
Wait, the intercept will be
See,
I. Okay, yeah,
P is equal
yeah,
to K upon V.
yeah,
I'm just using this equation. I can use this too. But since I need 1 by V and I don't need to fight with
yeah,
maths, that's why I just did the log P, and I can do this as, wait a minute, let me make it more simple for myself. K into 1 by V. So I can write
yeah.
K into 1 by V, and I can also write log K plus log 1 by V, right?
Yes, yeah,
And this is your log P. And you know that this is your log 1 by V, which is on x-axis, which is directly proportional to, and this is your log P, which is on y-axis.
yeah,
Now, this is your intercept, right?
yeah,
Y is equal to mx plus c. If
yes.
c is positive, then it comes here. If c is negative, then it comes here, because this is the intercept we are talking about. If c is
Uh,
negative, so that means you are going to extend this line, and this is your negative part. If c is equal to 0, then it will go through this. Are you getting my
okay, okay,
points?
yeah, okay.
So this is
Yes,
the top.
yes, okay.
Can I change the slide?
Yeah, yeah,
Okay. Now you know that P is inversely proportional to V, right?
yeah,
And
yes,
density is equal to M by V, mass per unit volume. That means density is also inversely proportional to volume. What do you think between the relation? What will be the relation between P and D? D for density, P for
Yeah,
pressure.
it'll be directly proportional.
It will be directly proportional.
Yes.
Hmm. So P is directly proportional to D. That means P is equal to KD, and that means P1 upon D1 is equal to, we can write P2 upon D2, right?
Yes. Yes. Yes.
In case of P1 V1 is equal to P2 V2, right? P2
Yeah.
V2. We can write this. Okay, you have seen this formula.
Yeah.
Now you know that when you are going upward, that means when you are going to mountain, the density of air decreases, or you can see uh, the pressure of air decreases. Yes or no?
Yeah. Yes.
And that's why density of air also decreases, and we feel thickness at the altitude.
Ah. Okay.
And when the pressure is lower, the mixing or the solubility of oxygen is air will be lower, and that's why we feel we will have breathing problem. Are you getting my problem?
Yes. Yes.
Are,
Yeah.
not my problem. Are you getting my point?
Yeah. Yeah.
Yeah. That's why we feel breathing problem at altitude, because pressure there will be lower and density will also be lower. And since pressure is lower, that means solubility will also be lesser.
Less. Yeah. That's Henry's law, right? Same.
What did you say just?
Yeah. It's like the Henry's law, right? Like P
Yeah,
and
yeah,
yes.
yeah, got it. It's like Henry law. We can say that. Yes, we can say that. Okay.
Yes.
Can
Yeah.
we move to the next part?
Yes. Yes.
Now, there is a very good question that is on this graph that I'm going to give you. There is a graph between PEV like this, and this is given that T1, T2, T3. You have to calculate a relation between T1, T2, T3. T1 is equal to T2 is equal to T3, or T1 greater than T2 greater than T3, or T3 greater than T2 greater than T1, or this is the C option. D option is insufficient or none of this. What do you think?
Wait. We have to use the PV is equal to nRT. That formula.
Yeah, you can use that.
Okay. Okay.
Hmm.
Yeah. T1 is greater than T2 is greater than T3.
Very good. Hmm. I'm impressed, man. Now see.
Okay.
These are all, and again do the same. The relation between
Okay.
T1, T2, T3.
Yeah. Here also same, right? Like no. T3 is greater than T2 is greater than T1.
How you are solving it? What is the
Like
concept behind it?
like PV is equal to nRT, then I draw like one line.
Okay, okay, got it.
Yeah, yeah.
Like this, you just put P
Yes, yes.
constant or this like
Yeah,
you can
V
take
one
any
by
one
V.
of them as constant, right?
Yes, yes, yeah.
Okay, okay, very good, very good. This is what I wanted to hear. Now you know
Yeah.
Charles law.
Charges proportional temperature, right? Like pressure and temperature.
Yeah, yeah,
Volume
yeah,
and
yeah.
temperature. Yeah.
Volume and temperature.
Okay.
Galois law is pressure directly proportional to temperature. Okay.
Okay.
Avogadro law that represents basically volume directly proportional to number of
Yes.
moles.
Okay.
And after combining all these equations, you will be getting PV is equal to nRT, right?
Yeah, yeah.
And you know that PV upon T is equal to NR.
Yes.
So there will be a formula P1 of V1 upon T1 is equal to P2 V2 upon T2 when number of electron are constant. When number of electron are constant, E and R is also already constant. So P1 V1 is equal to P2 V2
Wait, number
T2.
of a mole, right?
Yeah, when number of moles is constant.
Okay. Yeah.
Okay. Then P1 V1 upon T1 is equal to P2 V2 upon T2.
Yes. Okay.
Okay.
Yeah.
So this is what I wanted to tell you. And also remember this part is very important. If T into R, that T is equal to 0 degree centigrade, that means 273 and 0.0821. So it will be approximately equal to 22.4. And 1 by R, that is equal to 1 upon, if you are going to put the value 0.0821, it will be equal to 12.1. The value, this is very important because in this chapter, it comes regularly or frequently. Okay.
Oh, okay. Okay. Okay.
Only for the numerical purpose. And you also know that there is a relation between, we have already defined this, right? Density
Yeah.
directly proportional to pressure. But do you know we can use this in the in ideal gas equation?
Okay.
Ideal gas equation. Basically, you know that PV is equal to nRT, right?
Yes.
And I can write this nRT upon V. And
Yeah.
N we can write given mass upon molar mass. I can write this, right?
Yes.
And I
Yeah.
can also write this M upon V. It's my choice,
Yeah.
right? Now,
Yes.
mass per unit volume that is equal to density
Density.
into RT upon M. So this density is equal to MP upon RT. That I generally call it Madhya Pradesh upon Rajasthan. Okay,
Okay.
have you heard?
Yeah. Yeah. Yeah.
So density has a formula molar mass, P for pressure, R for constant, T for temperature. And we can do the question on this. Okay.
Okay.
Okay. So I'm going to give you a very good question on this. Can I change the slide?
Wait
Not
one
at all.
second. One second.
Yeah. So your paper is in 24th.
I I mean, they still haven't released my exam dates. It can be anywhere from 24th to 31st. Still didn't release that.
So I think this is our last class. Or
I'll see. I'll see. I think maybe.
okay. Yeah, yeah. Because you need to do by yourself.
Yes.
Now it's time. Okay, if you have got any problem or in any question, you can connect whenever you want.
Okay. Okay. Yeah.
Yeah.
Yeah. Done. Done. Yes.
Hmm. Okay, the question is register of 1 gram of ideal gas at 27 degrees centigrade is found to be 2 bar. When 2 gram of another ideal gas B is introduced in the same flask at same temperature. The pressure becomes 3 bar. Find relationship between their molecular mass.
Okay. Yeah.
Yeah. Let me know.
Yeah, not getting like the mass or like how to use
Not
that.
getting it's easy. Okay, okay. Just
Okay.
see. Whenever there will be any type of question, you need to extract information from there. And you can see there is a B and there must be an A. That means
Yeah.
pressure of 1 gram of an ideal gas A. Just let's
Yeah.
say there is A that is 1 gram. That is what I'm going to write it here. It is 1 gram,
Yeah.
temperature of 27 degrees centigrade, and both have same temperature, so we don't need to deal with this temperature. Okay.
Yes. Yeah.
Now, mass is given, pressure is also given. Partial pressure of A is 2 bar, right?
Yeah. Yes.
Now, when 2 gram of another liquid, another ideal gas B is introduced in the same flask. When A was there, The pressure of this container was 2 bar. Are you getting my point?
Yeah. Yes.
When B is introduced in this, the pressure of this container becomes 3 bar. So that means pressure of B will be equal to 1 bar. Yes or no? The total pressure is sum
Oh,
of all the partial pressure.
yes, yes.
Initially, when only A is present, the pressure was 2 bar. When B is introduced, the pressure of the container becomes 3 bar. The B is introduced in the same flask. You can see the pressure becomes 3 bar. Are you getting my point?
Yeah, yeah, got it. Yeah.
So now you are going to apply the formula PV is equal to nRT. Now you know pressure is 2,
Yeah.
volume V because they are in same flask. And here given mass of A upon molar mass of A into R into T. So can I write MA will be equal to WA, that is 1 gram given, right?
Yeah.
This is 1 gram. So I can take it as 1, that means RT upon 2V. I can write this. Okay.
Okay,
So
RT
for
of,
in case of
okay.
MB, yeah, is that clear?
Yeah, yeah, yeah.
Is that now for B, PV is equal to nRT, and you know for this is pressure of B. So pressure of B is 1 into V, and number of moles. This is given mass of B upon molar mass of B into RT, and you know that this part is 2 gram, right? So
Yes, yeah.
molar mass of B will be equal to 2RT upon V, 2RT upon V. So MB will be equal to 2RT upon V. So what you need to do, just take ratio, this V and V will be cancelled, and this RT and RT will be cancelled, right? And 2
Okay.
into 4. That means NA upon MB will be equal to 1 by 4. That means MB will be equal to 4 MA. This is the relation.
Okay.
So it's very easy, I think, right?
Yes, yes, yeah. Easy.
Yes, easy. Let me know when to change the slide.
Yeah, 1 second. Yeah, done.
Very good. Have you done question on problems related to open vessel? Problem
Yeah, maybe
relate.
before I had revised.
What did you say?
Yeah, I
Maybe.
think I did before. I need to revise that.
Very good.
Mm.
Problem related to open vessel. In open vessel, pressure is constant as well as volume is also constant. Are you getting my point?
Yeah.
That means PV is equal to nRT. You know that R is also constant. So we can do this. PV upon R is equal to NT. And this is constant, and it is always constant. That means NT is constant, right?
Yes. Yeah. Mm.
That means we can write N1T1 is equal to N2T2.
Oh, okay.
We
Okay.
can use this formula. So there is a question on this topic, and that is an open vessel contains air at a 27 degrees centigrade. Wait a minute. At what temperature it must be heated to expel 1/4 of air?
Okay.
Yeah, you can do. Let me know when you are done with this.
Yeah, wait. Yeah, 108 degrees, right? Oh, wait, in one minute. Actually, I in Kelvin.
Yeah, yeah, Calvin.
Mhm.
Do let me know.
Yes. Yeah, 381 Kelvin.
381. How did you solve it? Let's say. Just let me check. An open vessel contains air at 27 degrees centigrade. At what temperature it must be heated to expel one fourth of the air? So you can see, let's say initial mole is N. Are you getting my point?
Yeah,
And temperature T1 is 27 degrees centigrade. That means 300 Kelvin. Now,
yeah,
the final moles that is remained in the container is basically N minus N by 4. So this will be the
yeah.
3n by 4, 3n by 4, yes or no?
Yes, yes.
So this is 3n by 4 and T2 is we need to calculate. So I just told you our concept or so N1 is N, T is 300, N2 is 3n by 4, right?
Oh, okay. Yeah, yeah. Yes, yes. Yeah.
T2 is 400 Kelvin, where you had mistaken.
Okay. Yeah, first the N2 is equal to N minus N by 4. I just took
No. N
N2
by
is
4.
equal to N by 4. Yeah.
Yeah, yeah, yeah. So are you aware of this Graham's law of diffusion and diffusion?
No, I don't think. No, no.
You don't know. Okay. Just let me know when to change the slide.
Yeah, wait, wait. Yeah, done.
Very good. Now see. Graham's law of diffusion or effusion. Diffusion that means mixing of gases and diffusion that means you are going to make a small hole or pores and through which gas can escape. That is effusion. Okay.
Okay.
So we can write for diffusion the movement of gas in available space. Gas in available space is called diffusion. Okay. And when you
Okay.
are going to make a small hole and gas will escape or go, that is effusion. Okay. So according to this law, the rate of effusion or diffusion is inversely proportional to the square root of molar masses. Have you understood what is effusion and diffusion?
Wait, effusion one more time.
Effusion, just let me write this. The movement of gas from a small orifice, from a small hole,
Okay.
you can say, or orifice. That is called effusion.
Okay.
This is effusion. Are you getting my point? If
Yes,
you
yes.
had, this is diffusion. Now see, if you have this gas contains two types of gases or movement inside the container, that is diffusion. If any gas is going with uh, through this pinhole inside or outside, coming outside, that is diffusion.
Okay, okay.
Okay. So rate of effusion or diffusion inversely proportional to the molar masses. So R1 by R2 we can write, since R1 is inversely proportional to, so M1 will be here, and this is R2, it will be here. Are you getting my point?
Yeah, yeah, yeah. Yeah.
Yes or no?
Yes,
Okay.
yes.
So this is the rate of diffusion and effusion. And you also know that if you are going to increase the pressure, rate will be directly proportional. Rate of effusion or diffusion will be increased when you are going to apply the pressure. Yes or no?
Yes, yes. Yeah.
So R1 by R2 can be modified in this form, P1 upon P2 under root of M2 upon M1, because rate of effusion or diffusion will be directly proportional to pressure. If you are going to increase the pressure,
Yeah, yeah. Yes.
rate of effusion or diffusion will also increase. Can I change the slide?
Yes, yeah. Yeah.
Now see, rate of diffusion of gas in terms of volume. In terms of volume. So basically, rate is volume of gas per unit time, per unit time taken.
Okay.
So we can write R1 upon R2. You know that this will be volume V1 upon T1 upon V2 upon T2. We can write this
Yeah, yeah.
T2. And you also know that R1 upon R2 is equal to under root of M2 upon M1, right? So we can
Yeah.
equate these two equations because both are R1 by R2, and it will
Yeah.
be basically V1 into T2, because this will go in numerator, upon
Ah,
V2
yeah.
into T1, that will be equal to under root of M2 by M1.
Okay, okay.
In this, the question on this topic is directly mostly from the uh, formula point of view. You just need to
Okay.
remember the formula.
Yes.
Okay, can I change the slide?
Yeah, yeah, yeah.
Okay, rate of diffusion in terms of distance. It's all are same in terms of distance. As you can see, rate will be equal to basically distance traveled upon time taken, because distance will be traveled by gas in order to diffuse or effuse.
Oh, okay.
So basically distance traveled upon time taken. So we can directly write here, can I write it d1 into t2 upon d2 into t1? That will be equal to under root m2 by m1. Can I directly write it?
Yeah, yeah, yes, yes.
So it's all easy, right?
Yeah, it's easy.
So if I'm going to ask you a very easy question, and that is, write in order of write the order of rate of diffusion of following gas.
Like increasing order or decreasing? Like
Whatever you choose.
okay, yeah. Yeah, it will be helium, then methane, then nitrogen, then oxygen.
Very good.
Yes.
So it's quite easy, right?
Yeah, easy. Yes.
How's your general organic chemistry?
Yes, good. Yeah.
Okay, very good. So you didn't choose any date for your JMNs.
No, they are giving the date, right?
Oh, they are distributing the date, not
Yeah, yes.
you cannot choose it, right?
No, no, no.
So where will be the center?
Yeah, it will be in Riyadh, like a place in South, capital of Saudi.
Okay, okay, okay. Got it. And where you reside right now?
Yeah, in like Saudi Arabia, but another part, Dammam.
Daman. No, I'm aware of all that part.
Oh, okay.
Rate of diffusion of methane at a given temperature is twice that of X. Gas X. Find the molar mass of X. Please do it.
Okay, okay.
Let me know when you are done with this.
Yeah, 1 second. Yeah, 72 grams.
What did you say? 72 gram.
Yeah, yeah.
Okay, let me check it.
Okay.
So basically, mm, gas X. Gas is your X. If I'm going to write rate of methane and rate of gas X, what it will be? It will be basically rate of methane, molar mass of methane, yes or no?
Yeah.
And this will be molar mass. So I can write this as 16 and this is your molar mass of X. Now, according to the question,
Oh, wait, wait, wait.
rate
One
of
minute.
diffusion of methane. Yeah,
The answer is 64. Sorry, not 72,
yeah.
64. Okay.
It is 664.
Okay.
Okay,
Yeah.
okay. Now, the next question I'm going to give you is 20 decimeter cube of SO2 gas is diffused in 60 seconds. What volume of O2 gas is diffused under similar condition in 30 seconds? Let me know when you are done with this. Are you solving the paper that you have you got some paper for JE and NEET and JE?
Paper as in, like,
Like, let me read it for you. Wait a minute.
okay.
Like the board paper you were giving, right? Mock test.
Oh, yeah, mock test. Yeah.
And is there any other test that you were giving in Learnivio?
In Learnivio, like, yeah, mock test I'm giving. No,
Like
other than
only
that, no, no other tests. No.
okay, okay.
Yeah, I got 10 root 2.
That's good. It will be 10 root 2.
Okay.
Okay. So you also know what is ideal gas and what is non-ideal gas, right?
Yeah.
That
Yes.
means real gas.
Yeah.
So if I am going to ask you a question on that, you have read this chapter, right?
Yes.
That's good. Oh, wait a minute, please. Wait a minute, it's not working good. Write the order of attractive force. There are three types of gases A, B, C,
Ah,
D. four types of gases, in which gas the maximum attractive force will be there.
Okay, okay, wait, 1 second. Yeah, D,
Divide.
like it is deviating more from the ideal behavior. So it will have more attractive force.
Yeah, the maximum D, the
Yeah,
maximum
yeah,
attractive force. So this is the
yes.
concept now. If I'm going to write it T1, T2, T3 or TA, TB, let's say TA, TB, TC, TD, arrange them. Which one is greater and which one is. Are you getting my point?
Yeah, yeah, yeah. TA will be greater because more
Right.
less attractive force and more kinetic energy. Yeah.
Yeah. TA, TB, TC, TD, right?
Yes, yes, yeah.
That's great. That's great. Now, if I will ask you to arrange this NH3 and Cl2 in order of their attractive force.
Oh,
Now,
okay.
arrange them in increasing order or decreasing order of A. You know, A is van der Waals force. Van der Waals constant basically, right?
Yeah,
You
yeah,
know
yes.
this P plus A n square upon V square into V minus NB, right? Is
Yeah,
equal to
yes,
minority. So this A and B is van der Waals constant.
yes.
So if I'm gonna ask you which one will have greater value of A, what will be your answer?
Uh,
Yeah, A basically denotes attractive force.
okay.
So this will be greater because polar it is polar, so there will be attractive force.
Ah, okay. Yeah.
Are you getting my point?
Yes. Okay. Okay.
If my question is which one will be easily liquefied? Hmm.
Yeah, Cl2 because it is less van der Waals force. Right?
How do you know gas and here it is liquid in which force of attraction is greater? Force of attraction.
Yeah, liquid is greater. Yeah.
Liquid is greater. Liquid is greater.
Yeah.
You know that, right?
Yes. Yeah.
So, and in which the force of attraction is greater. If they are in gaseous state, in which this will have more
NH3,
force of
NH3.
attraction.
Yeah.
So
Yeah.
it is easier to convert, it is easier in NH3 to increase its force of attraction. And if the molecules is increasing, basically if the intermolecular forces of attraction between NH3 will increased, then it will be easily liquefied. It will be converted
Okay.
into liquid. Are you getting my point?
Yes. Yes. Yeah.
So also it is very important to note that if I'm going to ask you F2Cl2, which one will have more force of attraction or what will be the order of A in F2 and Cl2?
Are they equal? Will it be equal? No.
No, they will not be equal. Have you
Okay.
studied this methane and this is what? Ethane and this is your propane.
Yes. Yeah.
Can you tell me which one will have the highest boiling point or are the boiling point will be equal? What do you think?
Yeah. Longer the chain, like more boiling point.
Yeah,
So
you said
C.
it correctly,
Yeah.
but what is the reason behind it? Longer the chain, everyone knows that it will have longer chain. What
Huh.
is the cause? Do you know? Yes or no?
No, no, no.
So basically, van der Waals force of attraction is directly or molecular weight is directly proportional to van der Waals force of attraction.
Oh, okay,
So
okay.
that's why if the chain is going to be lengthy, the molecular weight increases and the force of attraction, which is van der Waals force of attraction, increases. That's why it has more boiling point than this and than this. So in this,
Okay.
it has more
CL2.
molecular weight, so
Yeah.
Cl. Got it?
Okay, okay. Yes.
Yeah. Can I change the slide?
Yeah, yeah, yeah.
Okay. So this is very important. And can you tell me which one? Speed. Speed are of three types, right? Here,
Uh, what one?
speed.
Yeah,
Speed.
speed.
That is basically in this chapter. There is another chapter or topic that is KTG, right? Kinetic theory of gases,
Ah,
in
yes,
which
yes,
we
yes.
study root mean square speed,
Yes, yes.
root mean square speed. Then comes your most probable speed.
Ah, yeah, yeah. Yes.
Then comes your average or mean speed. So I'm going to write it as VRMS. This as MPS, most probably. This as average. Can you arrange them which one is greater and which one is lower, smaller?
Okay. Is it like average is highest and then
No, no, no,
R
no.
must? No. Okay.
No, it's not like that.
Okay.
Basically, in this, VRMS is the highest. Then comes your average, and then comes your MPS.
Okay.
Let me show you the that is what I want to tell you is wait a minute. Yeah, Maxwell distribution curve. You have heard of it? Yes or
Yeah.
no? RMS is basically under root of 3 PV upon M. M is molar mass, and you know that PV is equal to nRT. So I'm gonna write N is equal to 1. So PV is equal to RT. For most probable speed, this will be under root of 2 PV upon M. And we can also write for one mole 2 RT upon M. Is that clear?
Okay, okay. Yeah. Yes. Yeah.
Now the third is average speed, and average speed is equal to 8 RT upon pi M, and that will be equal to RT can be written as for one mole PV upon pi M.
Okay, okay.
So
Yeah.
this formula is also quite easy. You can do this, right?
Yeah,
So
yeah.
these are the concept in states of matter.
Okay, okay.
Mm, okay. Is there any other chapter that you want to do?
Okay, well, let me see. Yeah, okay. Chemical bonding. Yeah.
Chemical bonding.
Yeah.
Okay, let me just start the question from chemical bonding,
Fine.
not the concept. What is
Fine.
just wait a minute, just wait a minute. Let me open the 1, 2, 3. Where are you? 45. Okay, there is a trick and it has been asked so many times. Do you know how to
Uh,
calculate the bond order very easily? Like,
yeah,
matlab, okay, can you tell me the bond order of N2?
yeah, it
O2.
is 3, right?
Yeah. Can you
3.
tell me the bond order of N2 minus 2?
Oh, minus 2. It'll be the 2 electron are there. Yeah, it'll be 2, 2.
Did you calculate? How did you calculate?
No, I just drew the structure like if 2 electrons are not there, then one bond is gone.
Okay, I'm just gonna give you a very
Yeah.
easy trick. Do you know the table of 2?
Yes, yeah, of course.
Oh, very good. 10, 12, 14. After 14 it's 16, then 18, then 20, and it is up to 20 only. This is
Oh,
the
okay,
number
I
of
didn't know.
electrons. This is the number of electrons, okay?
Yeah, yeah.
And this is your bond order. That is 1, 0, 1, 0, 1, 2, 3, 2, 1, 0. So if I asked you that N2 minus 2, right?
Yeah, yeah.
That means 16 electrons. So it is second order, bond order 2.
Okay. Okay,
How did
okay.
you calculate? I didn't get that. I want to know.
Uh, Wait, bond order is like the number of bonds, right?
Exactly.
Yeah, in N2 it is usually triple bond. And then when 2 electrons are not there, there is one bond. Oh, wait, 2 electrons are added. Yeah, wait. Okay, I
Oh,
thought of it as 2 electrons as
oh,
got
that
removed.
was Tukka.
Oh, okay.
Okay. So see, I'm going to give you a very,
Hmm.
very easy trick. If you have 6 electron, that means bond order 1. If you have 8 electron, that means bond order 0. If you have 4 electrons, that means bond order 0. And whenever bond order means 0, whenever bond order equals to 0, that means the particle or the molecule does not exist. Are you getting my point?
Oh, okay. Okay.
So whenever there will be question, generally if the molecule will be asked under 20 or up to 20 electrons, if you can count the number of electron easily, right?
Yes, yes, yeah.
And then you can get. If I am gonna ask you, Davis, that what is the bond order of N2 plus? It is N2 plus.
N2 plus, okay, only plus.
Yeah.
Okay.
So you are going to count the number of electron, which
13,
is
yeah.
13. So
Yeah.
13, look at 13. What is the number between 12 and 14? It comes between this,
Yeah,
yes or
yeah.
no?
Yes.
So what is the average number of this or mean
Oh,
midpoint of
okay.
this?
It'll be 2.5. 2.5.
So it is 2.5. Okay.
Okay, okay.
Also remember that bond order directly proportional to stability. Are you getting my point?
Ah, yeah, yeah. Yes.
Which is directly proportional to bond energy, which is inversely proportional to bond length. So if
Yes.
the question will be asked in terms of this, which one will be the or arrange them in increasing of order of bond length and all that. Okay, what you need to do
Okay.
first, calculate the number bond order. O2 bond order, that is quite easy.
Yeah, 2.
This is 17 electron, that is bond order is 1.5.
1.5. Okay.
O2 plus, that means basically uh, this is 17 electron, this O2 plus means 15 electrons, right?
Yes, yes. Yeah.
So what is the number 2
2.5.
and 3? It will 2.5. Very good.
Yeah.
O2 2 minus, that means 18 electrons, that means bond order is 1. If it has been
1.
asked which one has the highest bond length, it will be this, because bond order inversely proportional to bond length.
Bond length. Yeah, yeah. Yes.
And if it has been asked which one is the lowest bond length, so it will be sorry, O2 plus, it will be O2 plus.
Yes. Yes.
So this is how you can do it. In case you got the same bond order, in case you got the same bond order, are you getting my point?
Yeah, yeah.
If you have different atoms or different element, different molecules having same bond order, having same bond order, then how you are going to decide which one is more stable, which one is less stable?
Uh,
Are you getting my point or not?
yeah, 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 yeah.
So at that time, you have to do this configuration, sigma 1s, sigma star 1s2. Are you getting my point? And
Oh,
the
okay.
one which is having more electron in BMO, more electron in BMO, more stable,
Okay,
or
okay.
vice versa. Or more
Yes.
electron in ABMO, more electron in ABMO, less stable. Are you
Ah,
getting my point?
yes, yeah.
So it's very easy. There has been question that has been asked that PO4 minus 3, can you calculate the bond order of this? It is out of league, right? Or you can do it.
Uh, Wait, here can we use that table?
You cannot use the table because table is valid up to 20 electrons, right?
Ah, okay.
And this
Okay, okay.
phosphorus alone has 15 electrons.
Yes.
Oxygen alone has 8 electrons. That exceeds 20, right? And we have 4 oxygen,
Okay.
right? In this type of
Yes.
question, you are going to calculate bond order like 1 plus pi bond upon sigma bond. That means you are going to draw the structure, and I think you can easily draw the structure.
Yeah, yeah. Yes.
So 1 plus pi bond is 1 and sigma bond is 4. So here how you can calculate 5 by 4, that means 1.25 bond order. So you can
Oh,
easily calculate the bond order of CO3 minus 2 and all that. Okay.
wait, this is applicable for all compounds?
This type of compounds.
Okay, okay.
Okay.
Yes.
Basically this is not in our syllabus, but J we don't trust them. There's
Okay.
there will be some question that is out of league. So it is not that
Ah,
much.
okay,
This
okay.
is, are you getting my point?
Yeah, yeah, got it. Yeah.
Okay. Let me give you some question. So you know how to do hybridization, right?
Yes, yeah.
Okay. Okay, but for MOT, you have heard of this MOT, that is molecular orbital theory, which
Yeah.
is with the help of this, if the question will be asked for paramagnetic and diamagnetic of molecules, for molecules like O2 minus, Cn plus, and then NO plus, you have to do the electronic configuration according to MOT, like sigma 1s and sigma star
Yes.
1s. Okay,
Yes,
sigma
yes.
2s 2s star, sigma star 2s2. This, and you have to see whether the electrons are fully filled or electrons are paired or unpaired. Then you will decide. Okay.
Yeah, yeah, yeah.
Just let me search a very good question so that I'll be able to ask. Okay. So the question is very basic, and this is among the following, among the following molecules or ions, C2 minus 2, N2 minus 2, or 2 minus 2. Which one is diamagnetic and has shortest bond length? We need to tell them which one is diamagnetic and has shortest bond length.
Yeah.
Yeah.
I need a like a recap of the that MOT, the process. I made some mistake.
Okay, no problem. So
Yeah.
I just give you that you need to do the configuration, but here you can calculate the bond order easily. You can see we have
Yeah,
14
that is three.
electrons, then 3, then it becomes 2, right?
Two, yeah.
Then it is 1, and then
One,
this is
two.
2. So you can see it will have the shortest bond length, right?
Ah, yes,
Because
yeah. That,
bond order inversely, and you just need to check whether it is having uh, this is sigma 1s, sigma star 1s. Do you remember?
yeah, I know this part, yeah. Sigma
Yeah,
one and sigma
then
star.
tell sigma 1s, sigma star, sorry, 2s2, then sigma 2s2, then sigma star 2s2. Okay.
Okay, yeah, that is
After this, there is pi, right? Pi to
ah
px will be equal to pi to py. These are equal, and we have total number of 14 electrons, right? So 2, 4, 6, 8, 9, 10, 11, 12, 12, and then 14. So it is diamagnetic.
okay,
All the
okay.
electrons are paired.
Yes.
And shortest bond length, you can see if you're going to check, this is also diamagnetic, but it has the longest length,
Yeah,
wavelength, bond length.
yeah. Bond like that.
Yeah, yeah. So you need to take care of this also as well. Let me ask a question from VBT.
Okay, okay.
So the question is very easy. Total number of lone pair electron I3 minus.
Yeah, five lone pairs.
5 lone pair.
Oh wait, it's I three. Okay, either I then three like the
Wait a
top
minute.
node.
Total number of lone pair of electron. Uh,
I made mistake.
yeah. Total number of lone pair on I3 minus.
Yeah, 1 minute. Yes. Yeah, 10 lone pairs.
No, no, not 10 lone pair. It's So the 9 lone pair. The structure is basically like this. I, I, I.
Oh, okay.
3 lone pair each.
Within the
Basically, it
mine,
is, yeah, yeah.
the
I2
minus.
minus and I plus combine to form this I3 minus.
Oh, okay.
No, combination. Look with 3 lone pair each, and there is a negative charge on the square bracket. That's why there is a negative charge like this. You can write.
Okay.
Okay.
Yeah, yeah.
Do you know what is isoelectronic species?
Yeah, same number of electrons.
Okay, you know that. Okay, have you ever say this compound?
No, no.
CSI3.
Yeah, CSI3. No, I didn't know that. I don't know the
Okay,
structure. No.
okay, okay. It is a covalent. You need to choose the correct one, right? Correct statement. It is a
Okay.
covalent molecule. First one. Then comes here. It contains CS plus and I3 minus ion. Third one is it contains CS plus 3 and I minus. CS plus I minus and lattice I2 molecule.
Oh, okay.
Yeah.
Yeah, is it a fourth one?
No, not the fourth one. You know that
Oh,
cesium. This is already I had say, in the last I3 minus has a structure like this.
yeah, yeah.
Mm. So and cesium, you know, alkali metal have positive charge.
Positive. Okay.
It combines to form CSI3. Okay.
Oh, okay. Fine.
Okay. So please do this type of question and chemical
Yeah.
bonding very important. P block very important, and in organic chemistry, GOC the most important. Okay, there may be a
Okay.
question 2 to 3 question on this, which will be involved in other chapters also. And in
Yes.
physical chemistry, you know what to do, right? We
Yeah,
discussed.
yeah, yeah.
So this is it for today, and do let me know if you don't need class 2 because this is this time for you to revise and